our vision with this robot is checking all the deformations, leakages, damages or missing parts that are there. So this is the lubrication that is provided over here, and this is the lubrication tank. This is available in zigzag across the six motors. So 3 on the right side and 3 on the left side. So this is what one thing we have to check. Another thing is contrast colors are provided where the possible deformations are there. So that is
Cracks.
possible cracks are there. So that is another important thing that we need to check. Also, what we learned here today is that for the wheel, in order to check the wheel deformation, they use go-no-go gauges, or they just put the gauges over here and check the tolerances. And this is the brake lining. This is also important, the brake pads and everything. We have to check for cracks over here as well. As you can see, the possible areas of cracks are marked with contrast colors, and there are few more colors over here and on the motor as well. Now there are 5 batteries on left side and 5 batteries on right side. Our idea is that the camera can move up. We can use a telescopic cylinder and a rotating camera. So either we will use 360-degree camera, or we'll use a ball joint or a recirculating ball screw to check all possible cracks and deformations that are there in the parts which are not exactly accessible to human eye, to the naked eye. For example, up there, the topmost portion, according to the inspector who was guiding us over here, he said the topmost portion is also important as well as the bottommost portion for the cracks. So it is not clearly visible. Yeah, to check all the foundations, we'll need to increase the height of the camera. So it will be keeping an adjustable height camera. Right now we have decided to use Insta360 as a camera. Provide a 360 view to the operator so that he can move around as per the need and convenience. Between every 2 motors there is enough space that the camera can go up and check for cracks. So it will be adjustable height, and the robot will automatically adjust its heights using sensors, various sensors. As soon as there is an obstacle, it will reduce its height, move on, and as soon as it finds space, it will come up again. So as described in the presentation, we will be using UWB sensors. Now we think this is a possible mount for the UWB sensors, as from this mount there is a clear view of the entire bogie. Also, this is a motor and there are 6 such motors across the bogie. So there will be lowermost points over here like this for six times across the bogie. Now as per the information collected over here, the lowermost point is the rail guard and the cattle, which is 120 mm clearance, and above that is the motor, which is approximately 30 cm clearance. Below that, no part will be there. So for us, what is important is line of sight, and this mounting point will give us a clear view of the robot across the bogie. For this specific model, the compressor and the blowers are all inside the bogie, and there is another model right in front of us where the compressor is outside. So in order to make the model more flexible with the model, in order to make the robots more flexible with the different kinds of model, we need to integrate a few more sensors and also a few more algorithms that will help us program the robot as per the need of the various bogies.
Yes.
To program the robot as per the need of various bogies.